Hello and welcome back to Calculus 1, the final section of Chapter 4, Antiderivatives. The title already says what we're doing. We are undoing the derivatives. So we know that the derivative of x squared is 2x, which would mean that the integral of 2x dx is going to be x squared. But wait, the derivative of x squared plus 5 is also 2x, and that would say that the derivative of 2x dx will return again x squared. So we immediately see an issue here, that if we are to reverse the mathematical operator and try to discover the, let's say, the origin, right? Original function, you will see that it cannot detect that there was a plus 5 there, because the derivative destroys that information. So we have to fix that. And the way we fix that is, we say every time when we do the indefinite integral, the antiderivative, we put this plus c at the end, signifying that there could have been some value there, like we have plus 5 on the second one, that we have no information about for now. So that plus c there is not for decoration. It is extremely important. Now we do put plus c now, and students forget that on the Calc 1 exams and homework and labs a lot, so it's -1 every time you do that. I usually say it's either plus c or -1, you choose. But the trick here is that it serves huge purpose in later coursework, and especially in differential equations, where the entire solution depends on how well you treated that plus c. So right now, you just you see the why you need to put plus c every time you take the antiderivative. Now, are you going to memorize new formulas for this? The answer to that question is, for most part, no. What you are going to realize here is that these are backwards derivative. So what's the integral of cosine? Sine. What's the integral of sine? Negative cosine, right? What is the integral of 1 over x? ln x. Because the derivative of ln x is 1 over x, the integral of 1 over x must be ln x. Your derivative chart is now going to be read backwards. There is only one formula that it's going to be opposite, because we can simplify it using algebra, and that is the formula for polynomials. You know that derivative of x to the n is nx to the n minus 1. The integral of x to the n dx is going to be x to the n plus 1 over n plus 1 plus c. So that's the only formula that you don't get to read backwards. Everything else you are going to simply read backwards. What is the integral of e to the x? E to the x. What is the integral of secant x times tangent x? Secant x, right? Because the derivative of secant is secant tangent. Integral of secant tangent is secant, right? So we are not learning new. We are just undoing what we learned before. Now, we're going to have 3 chapters following this lecture that only deal with integration, and that only scratches the surface of integrals, because you are going to have later on, as you can see, double integrals in Calc 2, triple integrals, again Calc 3, triple integrals in spherical and cylindrical coordinates, which arise from polar coordinates, and so on. All of this is, I said to my students last night, if you're going to get a tattoo, there you go. That equation right there. That's a good one, all right? So, yeah, I know, right? That's why you go to the gym, right? You have a lot of real estate. Exactly. Or you can just eat a lot. I mean, there's always that. Like when you order the wrong t-shirt size by accident, it's like 2 sizes larger, you can just grow into it. That's easy. Right? So now let's do a whole bunch of these problems. What is the integral of x to the 4th dx? There you go. Yeah, -1. All right. Integral of square root of x dx. What should I do here? Nice. Make it x to the 1/2 and then unleash the formula. Formula says +1. How much is half plus 1? 3/2 plus c. And then we can fix this into 2/3 x to the 3/2 plus c. Nice. What is the integral? Oh, what's the integral of 4? 4x. You're just saving her skin every time. What is the integral of e to the x? A dx plus c. Nice. What is the integral of negative cosecant squared x dx? Nice. Good. What else? The same rule applies like for derivatives. You can have the product and the constant, the sum, difference, and the constant multiplication. You cannot have the products, you cannot have the quotients. There will be some formulas and substitutions and things coming out later to deal with that kind of stuff. So, how do you deal with integral of 2x cubed plus 5x minus 1? And you have to put in parentheses, everything in parentheses. So 2 is a constant. You will copy 2. And what is your integral of x cubed? Okay. Plus, you will copy the 5. That's the constant, just like derivatives. You copy the constants. And then what's the integral of x? Very good. And now, minus integral of 1 is, and then plus c. Nice. So these guys cancel. For the final answer, 1/2 x to the 4th plus 5/2 x squared minus x plus c. C. Whatever's going to make you remember it. I don't care. All right. How about this one?
Over 6 plus cosine x plus c.
Nice. So we have each one of these is going to be integrated separately. So we have x to the 6 over 6 minus negative cosine x plus c for a total of, you can write it as 1 over 6 x to the 6, whatever, plus cosine x plus c. So let's see some exercises. What happened?
Remember that
Burgers marinating? Oh, I know very well what it means. I do. That's what I do.
That's probably the main reason why Jim's so much awesome. It's like he's eating like a ton of meat, so he talks about the whole job.
Like the most manly thing ever. He works out so he can eat.
That's also why I'm not coming.
He always looks on my paper.
Hmm?
Six x 3 over 2 minus 2x to 1/2.
I'd say so.
Nice.
The first order of business is to rewrite this so that we can deal with exponents easier. So integral of 4x to the 1/2 minus 4x to the negative 1/2. So that would be the first thing to do.
I was wrong.
Yeah.
Oh, I misheard that.
To look at her glow now.
Double fractions.
So we have 4 times, we have x to the 3 halves divided by 3 halves, minus 4 times x to the positive 1 half divided by 1 half, and then we have plus c. So that's 8 over 3, x to the 3 halves, minus 8 x to the 1 half plus c. No product rule, no quotient rule here. We have no chain rule. We have methods that work those things backwards. They're called U substitution, integration by parts. We have trigonometric substitution. We have all bunch of stuff that is coming up in Calc 2. So during Calc 1, if you have division, most likely you have to divide. If you have multiplication, most likely you have to FOIL multiply. So what is the integral of x plus 1 squared times x minus 3 dx? What do you have to do here? What do you have to do? You have to multiply everything out. You have to square the first one, right? FOIL it, and then multiply that by x minus 3. Now, what's important is once you're done with all of that, you will have to have everything in parentheses and then dx at the end. The reason is all of this, guys, I will teach this next week, but I need you to know why I have to have these, why I have to see these parentheses. For notation purposes, it will be this times dx, and that will give you area as height times the width, or width times the length, or whatever. So it's actually multiplication where this dx is a very short, a very narrow length. Okay, so we have to FOIL, which gives us x squared plus 2x plus 1, and that needs to be multiplied by x minus 3. So I have x cubed, then I have plus 2x and minus 3x squared, so minus x squared. Then I have plus x plus
Minus 6x and then plus x.
minus 5x, yeah. Minus 5x and then minus 3. There we go. And now you get to integrate each one independently. So that's going to be x to the 4 over 4 minus x to the 3 over 3 minus 5x squared over 2 minus 3x plus c.
Is it plus 3x? Oh, no, that is a minus. Well, I thought that
Yeah,
was-
look, minus.
Yep.
See? And
Copy your-
it's right there. Minus.
I'm just gonna fix it up. It's easier out there to see it. Yeah. It's in there, 15-second lag. Great.
It's actually called the delay, and it's there for purpose, because if you're streaming video games and you're playing, you know, delay.
Got mad, you let it secret out. Oh, now we're back.
No, you actually have option to enable it, disable it, change the amount of delay. All those options are there. What do we have to do here? Right there. There's -1 in every little bush over here. Like, haha, -1.
Just like watch over everybody's shoulder while they're taking the test and make that noise. It's like, yeah, they'd figure it out and not, not have -1, but we'd all get a good laugh out of it. All of a sudden, everybody's taking the test.
Ooh, this is a good one. 5th root of r squared dr. What happened?
Oh, there we go.
Nice thing about these is people actually
Is the stream really dead? No, it's...
No, it died for a second, but it came back like right before we even started the last problem. So it was good time. Good time.
What should I write first?
Make it a fraction.
Make it a fraction. So what should I write? R to the 2/5. So now what is that equal to? Nice. Now where would we be without trig, right?
Lost the calculator.
Exactly. So let's do some of these wonderful problems, such as what is the integral of secant squared theta minus 1 d theta?
Is it? It's on.
Well, it's not tan squared, it's just tan.
Negative 10.
Tan minus
It's a trig I didn't know.
tan is secant squared.
Yeah.
What happened? So where do we start?
Pythagorean identity? Or am I overthinking it?
You might be overthinking it, because what is the
Has to be +1.
what's the derivative? Which derivative gives secant squared?
Yeah.
10. So we don't have to touch anything. We just go.
Oh.
The integral of 1. No excess thetas.
That was my fault.
Alright, now, you know how when we did derivatives before you learned about the chain rule, I asked you to memorize something real quick and then retire it later. You remember this? And then also we had the one for trig. Well, now we're going to do the same thing for integrals. We are going to memorize for a short while, and then by 5 we can filter it out. So the integral of sine ax dx is going to be negative cosine ax over a plus c. Now, guys, it should be common sense. If the special stuff was happening with the derivatives and it was multiplying, now it will be dividing. Bueno? So now you think about all of the trig functions. Let's take a look at one of the. Let's say you have cosecant ax cotangent ax dx. So what is the cosecant cotangent the answer of?
It's negative cosecant.
Negative cosecant ax divided by a plus c. You have 6 of these. So how about the integral e to the ax dx? Yep. Is that all? Oh, really? You would think I would know by now. That was a good save. Alright, so let's see what wonderful examples. So we'll do 2 examples now, and then I have something extremely important to write down. We have time. So first, let's take a vanilla example here. What do we have in this case? What happened? He is right. Yeah. So we copy 4. Derivative of cosine is positive sine. So we have sine 3t divided by 3 plus c. So 4/3 sine 3t plus c. Nice. Integrals. One more of these. Quick. We already had this question, but eh. So secant 4 theta, tangent 4 theta, d theta is what? No. I'll be up for 2 days. Nice. All right, so now this is going to be something extremely important. Need this Calc 2, Calc 3, you need this in the future. And it's a power reducing formulas. So sine squared x is 1 minus cosine 2x over 2, and cosine squared x is equal to 1 plus cosine 2x over 2. So these formulas are the only way to integrate sine squared and cosine squared. So if you have the integral for this, if you don't know these formulas, you can't do the problem. That's it. So you must know this. So what is the integral of sine squared x dx? Well, we write it as 1 minus cosine 2x over 2. We can kick 1/2 outside, have 1 minus cosine 2x dx, and now integrate separately each one of these. Integral of 1 is very good. And what's the integral of cosine 2x? Sine 2x. Divide by 2, close parenthesis, plus c. It's not there for decoration, I'm sorry. So the final answer, x over 2 minus sine 2x over 4 plus c. If you don't want the factor form, doesn't matter. Ta-da! What happened? Power reducing formulas for sine and cosine. They're absolutely imperative. They're going to show up a lot of times, polar coordinates and trig substitution, trig identities. They're going to be all over the place. You've got to know this. There's no other way to solve the question. Power reducing formula is what you need. There are no formulas given at RVCC for any of the classes. So, yeah. The answer is no. All right, that's it for today. We'll say bye to the stream.